Hello there. I'm glad you've arrived here tonight. The day has ended. The noise of the world is quieting, and this is your time to let go. Let your shoulders soften, let your breath deepen, and allow your thoughts to wander far beyond your room. Out there, past the moon, past the sun, past the stars you see in the night sky, lies a universe filled with mysteries. Some of those mysteries shine brilliantly. Stars blaze, galaxies spin, nebulae glow in radiant colors. But most of the universe does not shine at all. It does not glow. It does not sparkle. It cannot be seen. And yet, it is there, everywhere, shaping everything. Tonight, we will drift into that invisible realm. Tonight, we will explore the story of dark matter. Dark matter is a name for something both simple and profound. We cannot see it. We cannot touch it. It does not shine or reflect light. But we know it exists, because without it, the cosmos would be torn apart. Dark matter outweighs everything familiar. The planets, the stars, the gas, the dust, all of it, combined is only a fraction compared to the hidden mass. More than 80% of all matter in the universe belongs to this invisible form. Imagine that. Most of reality lies beyond sight, an unseen ocean in which the galaxies drift. As you listen, let each fact arrive softly, like ripples on a quiet pond. Each is a small truth, gathered by patient observers, stitched together into a tapestry of the unseen. The journey begins with wonder. How did we even discover something that cannot be seen? The answer is hidden in motion. Astronomers noticed galaxies spinning too fast. Their stars should have scattered into space, flung away by centrifugal force. But they didn't. They held together, bound by something invisible. That invisible something was named dark matter. Imagine yourself floating above a spiral galaxy. Its arms are wide, glittering with billions of stars. Near the center, the stars orbit quickly, as expected. But at the edges, far from the core, they still move just as fast. Gravity from the visible stars is not enough to hold them in, and yet they stay. The galaxy is embraced by an unseen halo, a cocoon of dark matter that binds it together. You cannot see this halo, but without it, the galaxy would fly apart. It is a gentle reminder that the most important things are not always visible. For nearly a century, scientists have traced the fingerprints of dark matter across the sky. They see its influence in galaxy clusters, in the bending of light around massive objects, in the cosmic web that stretches across billions of light years. Everywhere they look, there is more mass than meets the eye. It is as though the universe is built on hidden scaffolding, a vast skeleton of dark matter upon which everything else is hung. What is it made of? That is the great unanswered question. Some imagine new kinds of particles, heavy, slow, weakly interacting with everything we know. Others picture ghostly, feather-like particles drifting through space, passing through stars, through planets, even through you, without leaving a trace. Right now, as you listen, trillions of dark matter particles may be flowing through your body, unseen and unfelt. It is not dangerous. It is simply there, a reminder that we are immersed in something far larger than ourselves. And yet, for all its mystery, dark matter has been mapped. Astronomers use the light of distant galaxies as clues. When light passes through a cluster filled with unseen matter, it bends, curving into arcs and streaks. This effect, called gravitational lensing, is like nature's own magnifying glass. By tracing these distortions, scientists can sketch the outlines of invisible mass. They can see halos of dark matter surrounding galaxies, tracing filaments that stretch between them, forming the skeleton of the cosmos. You cannot see it directly, but you can see its shadow written in light. Let your mind drift into that image. The Milky Way, our home galaxy, is not just a spiral of stars. It is wrapped in a vast sphere of dark matter, extending far beyond the visible disk. Every star, every planet, every breath you take is moving within this invisible halo. You live inside dark matter, carried by it, bound to it, even though you cannot sense it. It is not an intruder. It is home. As you rest, know that dark matter is quiet. It does not burn like stars. It does not explode like supernovae. It is patient, steady, constant. It shapes the universe without demanding attention. And in that sense, it is like sleep itself, invisible, gentle, supportive, unseen but essential. Tonight, as you drift into dreams, let the thought of this hidden matter carry you. You are floating in its embrace, just as galaxies float, just as stars are held, just as the cosmos itself is steadied by the unseen. The story of dark matter begins almost a century ago, with a Swiss astronomer named Fritz Zwicky. In the 1930s, Zwicky studied the Coma cluster, a great gathering of galaxies far beyond the Milky Way. He expected that the visible mass, the light of stars, the glow of gas, would explain the gravity that held the cluster together. But when he measured their motions, he found something startling. The galaxies were moving far too fast. By all normal calculations, they should have flown apart. The cluster should have disintegrated, its galaxies drifting into the dark. And yet, it remained back. Zwicky called the missing ingredient Dunkel materia, dark matter. He meant it simply as unseen mass, something that could explain the gravitational pull. At the time, his idea was treated with skepticism. Many thought he had miscalculated. Others assumed the observations were flawed. The notion of invisible matter sounded implausible, almost like a ghost story told through equations. But Zwicky was confident. He insisted that the universe contained far more mass than anyone had imagined. Imagine standing at the edge of that cluster, watching hundreds of galaxies dance. Each one is vast, with billions of stars, yet their orbits around the cluster's center are smooth and steady. They are held together by something invisible. You cannot see it, but you feel its presence in the motion of the galaxies, in their refusal to drift apart. It is like listening to music carried on a wind you cannot see, invisible, yet undeniable. For decades, Zwicky's claim lingered at the edge of astronomy. Some remembered it, some dismissed it, but the mystery remained. More observations came in, more galaxies were measured, and slowly the whispers grew louder. The universe was not adding up. The light of stars could not explain the pull of gravity. Something unseen was everywhere. The real turning point came in the 1970s, when another astronomer, Vera Rubin, measured the rotation curves of spiral galaxies. She expected the stars near the center to move quickly, and those at the edges to move more slowly. That is how solar systems behave. Planets far from the sun orbit more slowly than those near it. But Rubin saw something different. No matter how far from the center, the stars moved at nearly the same speed. The edges of galaxies were racing as though some hidden hand held them tightly. That hidden hand was dark matter. The combination of Zwicky's clusters and Rubin's galaxies transformed dark matter from speculation into necessity. It was no longer just a curious possibility. It became a central puzzle of cosmology. If galaxies and clusters were held together by invisible halos, then dark matter was not rare. It was everywhere. It was the framework of the cosmos. Think of the elegance of that discovery. By looking at motion, at how things move and do not move, we uncover the unseen. We do not need to touch dark matter to know it is there. Its gravity is enough. It bends orbits. It curves light. It sculpts structures. Even now, you can imagine it, gently holding the Milky Way in its grasp, keeping every star, every planet, every person bound within its invisible sphere. And yet there is humility here. We know that it exists, but not what it is. The universe whispers its presence in equations and motions, but it has not yet revealed its nature. To fall into dark matter is to fall into a mystery we can describe. but not yet soul. It is both knowledge and ignorance, both clarity and question. As you drift deeper into rest, think of Zwicky, gazing at galaxies in the 1930s, daring to imagine that most of the universe was hidden. Think of Rubin, tracing stars with her telescope, finding patterns that defied expectation. Think of how these discoveries unfolded, not in explosions or flashes, but in patient observation, in quiet data, in whispers of truth. Dark matter's story is not loud. It is subtle, like sleep itself, steady and soft, holding everything together without fanfare. Picture a galaxy. From afar, it looks like a flat disk, a spiral of glowing arms winding gracefully around a bright center. Billions of stars sparkle like grains of sand in a vast whirlpool of light. Gas clouds shimmer, nebulae glow, planets orbit quietly around their suns. To the eye, it seems complete, yet what you see is only a fraction of its true form. Surrounding this spiral of stars is an immense, invisible sphere, a halo of dark matter that stretches far beyond the visible edge. These halos are vast, much larger than the galaxies they hold. If the glowing disk of stars were the size of a coin, the dark matter halo around it would be the size of a dinner plate, enveloping the galaxy in an unseen embrace. Without these halos, galaxies would not survive. The stars at the edges would drift away, flung into the void by their own motion. The spirals we admire in the night sky would unravel, but with halos, galaxies hold together. They are bound by the unseen. Astronomers discovered these halos by studying how galaxies rotate. The outer stars move too quickly for visible matter to keep them in orbit. Something else is adding gravity, something far beyond what telescopes can see. The only explanation is an invisible halo of mass, extending outward, heavier and larger than the luminous galaxy itself. Think of the Milky Way, our home galaxy. Its visible disk is about 100,000 light-years across, a broad spiral where hundreds of billions of stars shine. But its dark matter halo extends several times farther, wrapping our galaxy in a sphere so large it is hard to imagine. We live inside that halo, carried by it, embraced by it. Every motion of our solar system around the galactic center, every star orbiting in the disk, every cluster of gas, all are bound together by the gravity of dark matter. It is strange to think that halos dominate the structure of galaxies, yet we cannot see them. They have no glow, no shimmer, no reflection. They reveal themselves only in the way galaxies move, in the way light bends as it passes through them. When we observe distant galaxies through the lens of clusters, we see arcs of distorted light, curved and stretched by invisible halos. These gravitational lensing effects are like fingerprints of the unseen, marking the sky with proof of hidden mass. In computer simulations, halos are everywhere. When scientists recreate the universe inside powerful supercomputers, they include both visible matter and dark matter. Over billions of years, dark matter collapses first, forming halos. Then, within those halos, gas collects, cooling and igniting into stars. Galaxies are born inside dark matter cocoons. In this way, halos are not only guardians, they are wombs, cradles in which galaxies form and grow. Without halos, there would be no galaxies at all. Imagine drifting through one of these halos. There is nothing to see, nothing to feel, no particles to scatter light. Yet gravity tugs at you constantly. You would know you were inside not by vision, but by the way stars move around you, held in invisible orbits. It is like floating in an ocean of glass, unseen, untouched, but shaping everything. And the halos themselves are not uniform. They are lumpy, irregular, filled with substructures, smaller clumps of dark matter orbiting within larger ones. Some of these clumps may host dwarf galaxies, tiny companions to larger spirals. Others may be empty, pure gravity, without stars. The Milky Way's halo is thought to contain hundreds of such subhalos, unseen companions orbiting with us, ghostly satellites we cannot map directly. The idea that every galaxy is wrapped in an unseen halo changes how we think of the cosmos. We are not living in islands of stars floating in emptiness. We are living in islands of light, floating in oceans of dark matter. Every galaxy is a pearl in a vast, invisible shell. The beauty we see in the night sky is only the surface. The true structure is hidden. As you sink deeper into rest, let that thought carry you. The universe is not only what you see. Most of it is unseen, supporting what is visible, binding it, holding it, just as dark matter holds galaxies together. Your own hidden rhythms hold you, your breath, your heartbeat, your quiet thoughts. You do not always notice them, but they are there, constant, steady, unseen. If you cannot see something directly, perhaps you can see how it changes the world around it. This is the gift of gravity. Gravity bends paths, pulls orbits, curves space itself. Even light, which we often imagine as untouchable, is guided by gravity's hand. When a massive object sits between us and a more distant source of light, the rays from that distant source curve, sometimes gently, sometimes dramatically. This bending of light is called gravitational lensing, and it has become one of the clearest signatures of dark matter. Imagine looking at a cluster of galaxies, billions of light years away. Beyond that cluster, even farther in the background, other galaxies glow. As their light passes through the cluster, it bends. When we capture the scene with a telescope, the background galaxies do not appear as simple points of light. Instead, they stretch into arcs, smears, even circles. Some are doubled, others multiplied, like reflections in a hall of mirrors. These distortions are not tricks of glass or atmosphere. They are caused by gravity itself. But here is the key. The amount of bending is far too great to be explained by the visible matter in the cluster. The galaxies and gas we can see are not enough. Something heavier must be present, sculpting the space, pulling the light into arcs. That something is dark matter. Lensing is its fingerprint. A shadow drawn not in darkness, but in the bending of light. Astronomers use these distortions to map the invisible. By carefully measuring the shapes of background galaxies, they reconstruct the distribution of mass in the lensing cluster. What they find is striking. The maps show halos and filaments of unseen matter, clumps and knots that outweigh the visible galaxies many times over. The light of the universe becomes a tool to reveal its shadow, painting a portrait of the unseen. One of the most famous examples is the Bullet Cluster, a pair of colliding galaxy clusters observed in the early 2000s. As these clusters smashed together, the gas clouds within them collided and slowed, glowing in X-rays, but the dark matter halos, unaffected by collisions, sailed past one another, leaving the visible matter behind. When astronomers mapped the mass of the Bullet Cluster using gravitational lensing, they found the bulk of the mass separated from the visible gas. It was a vivid, undeniable proof. Dark matter exists, and it behaves differently from ordinary matter. Think of how profound that is. In the Bullet Cluster, we see dark matter revealed not by what it is, but by where it is not. The luminous gas glows in one place, but the gravity lies elsewhere. It is like watching shadows move without the figures that cast them, like seeing footprints without the feet. It is absence that proves presence, a paradox of the cosmos. Gravitational lensing does more than prove dark matter. It also allows us to measure it across cosmic scales. Surveys of the night sky, capturing millions of galaxies, reveal subtle distortions in their shapes. These weak lensing effects, averaged over vast areas, map the cosmic web. They show how dark matter forms filaments that stretch across billions of light years, connecting galaxies into a grand network. The visible universe, stars, galaxies, clusters, rides along these filaments like dew on a spider's web. Imagine drifting through that web. The filaments are invisible, but their pull is everywhere. Galaxies cluster along them, drawn to the intersections, where great knots of mass form clusters and superclusters. Between them lie vast voids, nearly empty, expanses of nothingness, stretching for hundreds of millions of light years. The universe is not evenly spread. It is a tapestry of light woven on a framework of darkness. And all of this is known because light bends. The straight lines we imagine across space are curved by unseen hands. The universe itself becomes a lens, magnifying, distorting, revealing. To fall into the story of dark matter is to fall into this bending of reality, where what you see is shaped by what you cannot. As you settle deeper into rest, imagine those arcs of light stretching across the sky. Background galaxies warped into crescents and rings by the pull of the invisible. Imagine the quiet patience of astronomers measuring those arcs, tracing them back to the hidden mass that caused them. Let that patience soothe you. Let the thought of unseen scaffolding calm you. The universe is vast, and much of it is hidden. But even the hidden leaves traces, bending light, shaping paths, whispering its presence in silence. Close your eyes and imagine stepping back, not just away from Earth, not just out of the Milky Way, but farther, much farther. Imagine you could shrink the entire observable universe into a map you can hold before you, billions of light years wide. At first you might expect it to look uniform, like a fog of galaxies, spread evenly in all directions. But the real universe is not even. It has texture, structure, an immense pattern woven into its depths. That pattern is the cosmic web, and dark matter is the thread. In this web, galaxies are not scattered randomly. They cluster along filaments, drawn together by invisible gravity. These filaments stretch across hundreds of millions of light years, connecting galaxies into chains, linking clusters into networks, threading the cosmos into a structure grander than anything on Earth. Between the filaments lie voids, vast expanses almost empty, where very few galaxies reside. The web is a map of both presence and absence, a dance of density and emptiness. Computer simulations show this web with haunting clarity. When scientists let the laws of physics play out inside vast digital universes, starting just after the Big Bang, dark matter collapses first. Tiny fluctuations in the early universe grow, clumping into halos and filaments. Ordinary matter follows, falling into the wells of gravity carved by the dark. Stars ignite, galaxies form, clusters gather. But always, it is the dark matter that leads, the visible matter that follows. The web belongs to the unseen, and the light simply hangs upon it. Our own Milky Way lies along one of these filaments, connected to neighbors by dark strands. It sits within the Laniakea supercluster, a vast region of space bound together by gravity, stretching over 500 million light-years. Within Laniakea, our galaxy is but one grain of light clinging to an invisible thread, itself woven into the greater cosmic web. To think of this is to realize how small we are, how immense the scaffolding must be, and how silent its presence remains. The cosmic web is not just beautiful, it is proof of dark matter's necessity. Without its guiding hand, matter would not have clumped into filaments. Galaxies would not have formed into chains. Clusters would not have grown at the intersections. The universe would be a fog, diffuse and dim, lacking the structure we see today. The very fact that we can look up and see galaxies grouped together is evidence of the invisible strands that hold them. And this web continues to shape the universe even now. Galaxies are not fixed. They drift slowly along the filaments pulled toward denser knots. Superclusters tug on one another, entire regions of the universe flowing toward unseen centers of mass. One such region is called the Great Attractor, a gravitational anomaly pulling galaxies, including our own, across hundreds of millions of light years. Its true nature is hidden, obscured by the plane of our galaxy, but its tug is undeniable. Once again, the unseen leads the way. Imagine floating through the cosmic web. You would see glowing galaxies tracing invisible threads, lines of light stretching into the distance. Between them, emptiness, vast voids where few stars reside. The contrast would be striking, not chaos, but order, a structure shaped not by chance, but by gravity. And at its heart lies dark matter, silent, patient, unseen, weaving the cosmos as though it were cloth stretched on a loom. As you rest, let the image of that web settle into your mind. Picture the threads connecting galaxies, the filaments carrying light, the voids opening wide between them. You are not separate from this web. You are part of it. Every atom in your body sits within a galaxy, which sits within a halo, which sits upon a filament, which is one thread among countless billions. The web holds you as surely as it holds the stars. It is not a cage, it is a cradle. To understand the importance of dark matter, you must journey back to the beginning, to the first moments after the Big Bang. The universe then was not filled with galaxies or stars. It was filled with energy, expanding rapidly, cooling into particles of matter and light. In that early fireball, ordinary matter, the protons, neutrons, and electrons that would one day form atoms, was tangled with radiation. Light scattered constantly, preventing matter from clumping. The cosmos was a glowing fog, uniform and bright. But dark matter was different. It did not interact with light. It slipped through the fog untouched, pulled only by gravity, while ordinary matter was caught in the dance of photons, bouncing and scattering. Dark matter was already collapsing into clumps. These clumps became the seeds of structure, the first wells of gravity in which galaxies would form. Without dark matter, the early universe would have remained smooth for far too long, and stars and galaxies might never have appeared. This difference is written into the cosmic microwave background, the faint afterglow of the Big Bang, still visible today. When scientists map this light, they see tiny fluctuations, slightly hotter spots, slightly colder spots. These ripples show where matter was beginning to gather, where the first seeds of galaxies were planted. The patterns cannot be explained by ordinary matter alone. Dark matter's gravity was already at work, amplifying the clumps, drawing matter into filaments. Its presence in the first 400,000 years of the universe is etched into the oldest light we can see. Imagine the universe then, only a fraction of its current age, glowing like a hot ember stretched across the sky. To our eyes, it would have been opaque, filled with blinding light. But beneath that surface, invisible to vision, dark matter was forming the scaffolding. The galaxies we see today, the stars that shine, the planets that orbit, all trace back to those invisible patterns. Dark matter was the quiet architect of creation, shaping the cosmos long before the first sun was born. When the universe finally cooled enough for atoms to form, light was freed. The fog cleared, and the cosmos became transparent. Ordinary matter could at last fall into the gravitational wells carved by dark matter. Over hundreds of millions of years, the first stars ignited, clustering into galaxies along the invisible filaments. From those galaxies, clusters formed, and then superclusters. The structure of the universe unfolded, guided by something we still cannot see. Think of how profound this is. The universe you live in, the stars you see above, the planet beneath your feet, are all consequences of the invisible. If dark matter had not existed, the sky would not be filled with galaxies. The universe would still be diffuse, thin, empty of complexity. You would not be here to wonder about it. Life itself depends on what we cannot see. And so, dark matter is not a footnote. It is not an accessory to the universe. It is the foundation. It shaped the early cosmos, carved the filaments, guided the light, Every galaxy is a monument to its influence. Every star is a child of its gravity. Every breath you take is possible because, long ago, dark matter collapsed where light could not, planting the seeds of existence. As you let your body rest, allow that thought to settle. You are not separate from that story. You are part of it. The atoms in your body once drifted in that early fog. The galaxies that light the sky grew in halos that formed before Earth existed. The rhythm of your breath is linked to the quiet patience of dark matter. The universe is not only vast, it is hidden, and it has always been hidden. When faced with something mysterious, the first step is often to ask, what is it not? Dark matter has puzzled astronomers for nearly a century, and though we do not yet know its true nature, we do know many things it cannot be. Ruling out the possibilities is part of the quiet progress of science, and each exclusion sharpens the mystery, making the unseen more defined. Dark matter is not the stars we already see. The glow of billions of suns can be measured, weighed, and counted. Their light fills the night sky, and our telescopes capture it across vast distances. The stars account for only a small fraction of the total mass in galaxies. Even when you add in the faintest stars, the cold dwarfs, and the burned-out remnants of old suns, the sum still falls far short. The light we see cannot explain the gravity we measure. Dark matter is not gas or dust. Astronomers can detect gas clouds across galaxies, even the cold ones, by the way they absorb and emit radiation. Dust glows faintly in the infrared, revealing itself in surveys of the sky. Yet when all this material is counted, it remains too little. Even the hidden reservoirs of cold hydrogen, invisible to ordinary telescopes, cannot provide the missing mass. The unseen scaffolding is heavier, more pervasive, beyond what ordinary matter can supply. Dark matter is not simply black holes scattered through galaxies. Once, this idea had some appeal. Perhaps the invisible mass was made of collapsed stars, quiet and dark. These objects, called machos, massive compact halo objects, were tested. Astronomers searched for them using microlensing, watching for the way a black hole might briefly magnify the light of a distant star as it passed in front. But the results were clear. Machos exist, but not in numbers large enough to account for the vast weight of dark matter. The halos are far too massive to be explained by hidden populations of black holes or brown dwarfs. Dark matter is not antimatter. If the cosmos were filled with invisible antimatter, it would collide with matter at the boundaries, releasing floods of energy. We would see the annihilation in gamma rays, bright and unmistakable. The sky holds no such glow. Whatever dark matter may be, it does not behave like antimatter. Dark matter is not light itself. Some speculated about exotic forms of radiation, hidden photons, or unknown wavelengths. But radiation does not clump. It streams outward at the speed of light, dispersing rather than gathering. The halos we see, the filaments that hold galaxies, require something that binds, something that pulls inward. Dark matter is heavy, massive in some form, though invisible to every detector of light. By crossing off these possibilities, scientists have narrowed the field. We know dark matter is not ordinary matter we have overlooked. It is not faint stars. It is not gas, dust, or black holes. It is not antimatter. It is not light. What remains is more exotic, new kinds of particles beyond the catalogue of physics we currently possess. And this is where the mystery deepens. To imagine dark matter is to imagine a shadow world, made of particles that drift through us without a trace, bound by gravity, but almost nothing else. The very fact that it does not interact with light is why it remained hidden so long, and why it remains so hard to capture even now. As you rest, let this thought comfort you. Science is not always about the answers we hold. It is about the questions we refine. Dark matter is still a mystery, but we know enough to say what it is not, And in those empty spaces, in those ruled-out roads, lies the shape of the truth to come. If dark matter is not the familiar stars, gas, dust, or black holes, then what is it? The most compelling idea is that it is made of particles. Particles unlike any we have ever touched. Particles that do not shine. Particles that rarely if ever collide with the matter we know. These candidates have names that sound both technical and dreamlike, whispered in the halls of physics as possibilities waiting in the dark. One of the leading candidates is something called a WIMP, a weakly interacting massive particle. The name tells its story. These particles would be heavy, carrying mass, but they would interact with ordinary matter only through gravity and perhaps the weak nuclear force. That weakness makes them invisible to our detectors. Trillions of them could pass through you every second without leaving a single trace. Yet their mass would be enough to shape galaxies, bind clusters, and weave the cosmic web. WIMPs became the cornerstone of dark matter theory for decades, inspiring countless experiments to catch even one. Another candidate is the axion, a particle so light it is almost weightless, proposed originally to solve a different problem in particle physics. Axions, if they exist, could be produced in vast numbers, forming a sea of invisible particles drifting through space. Unlike WIMPs, they would not be massive individually, but together they could add up to the universe's missing mass. Detecting axions would require extraordinary precision, instruments sensitive enough to catch faint oscillations in magnetic fields. Whispers of their passage, there are also ideas about sterile neutrinos. We already know 3 types of neutrinos: ghostly particles born in nuclear reactions, streaming out of stars and supernovae. Neutrinos are so elusive that trillions pass through Earth every second, barely interacting. But sterile neutrinos would be even more hidden. A new type that does not even interact via the weak force. Their existence is speculative, but if real, they could explain the dark matter puzzle. Physicists have gone further still. Some imagine entire families of particles, a whole dark sector, with its own forces, its own interactions, perhaps even its own versions of atoms and structures. In this view, dark matter might not be one simple particle, but an entire hidden world overlapping ours. It would be invisible, but not empty, filled with its own richness, its own invisible physics, its own quiet dance. Others think of dark photons, cousins of the photons we know, carrying energy in a hidden form. There are even theories of extra dimensions, where dark matter is the shadow of matter leaking into our world from beyond our perception. These ideas are speculative, but they remind us of the breadth of imagination the mystery inspires. The one thing all these candidates share is subtlety. Dark matter does not reveal itself easily. It is silent, passing through detectors, through planets, through you and me, without a sound. To catch it is to wait with extraordinary patience, to build instruments that can sense the rarest whispers, to sift through silence for the faintest signals. As you drift deeper into rest, let these possibilities unfold in your mind, like stars in a dark sky. Perhaps dark matter is heavy and rare, like WIMPs. Perhaps it is light and numerous, like axions. Perhaps it is ghostly, like sterile neutrinos. Perhaps it is something stranger, something we have not yet imagined, something waiting beyond the horizon of our knowledge. The truth is unknown, but in that unknowing, there is wonder. We are surrounded by a universe that hides more than it reveals. And yet even in its silence, it gives shape to everything. You are lying beneath its pull, resting in its gravity, carried in its embrace. Dark matter is with you, always, unseen but constant, mysterious but real. Once the idea of dark matter began to settle into astronomy, not everyone agreed it had to be exotic. Some wondered if the solution could be simple. Perhaps the missing mass was not made of strange new particles at all, but of ordinary objects that were merely too faint to see. These possibilities were called machos, massive compact halo objects. The The name was chosen as a playful counterpart to WIMPs, but the idea was serious. Could dark matter simply be hidden stars, burned out remnants, or black holes scattered throughout the halos of galaxies? Imagine the outskirts of a galaxy, far from its bright spiral arms. In the darkness, there might be countless faint stars, brown dwarfs too small to ignite fusion, glowing only dimly with heat. There might be white dwarfs, the husks of dead stars, cooling slowly over billions of years. There might be neutron stars, dense remnants of supernovae, or black holes, collapsed cores that swallow light. If these objects filled galactic halos in vast numbers, they could account for the missing gravity. For a time, this idea was tempting. It required no new physics, no new particles. The cosmos would simply be full of faint or invisible objects we had not yet counted. But science demands evidence, and astronomers devised ways to test the macho hypothesis. They turned to a phenomenon called gravitational microlensing. When a compact object passes in front of a distant star, its gravity bends the star's light, magnifying it briefly. For days or weeks, the star appears brighter, before fading back to normal. By monitoring millions of stars in nearby galaxies, astronomers could catch these events and estimate how many hidden objects drift through galactic halos. The searches were carried out with great patience. The Macho Project, Eros, and Ogre collaborations watched the skies, scanning the Magellanic Clouds and the Milky Way's bulge. They found microlensing events, proof that compact objects do lurk in the darkness. But the numbers were far too small. Even if every faint star, white dwarf or black hole were counted, they made up only a fraction of the missing mass. The halos were far heavier than machos alone could explain. Black holes were especially intriguing. Could primordial black holes, formed in the first moments after the Big Bang, fill the halos? These ancient objects, born not from stars but from the collapse of density fluctuations, would be scattered across the cosmos, invisible except by their gravity. For decades, this idea has remained on the table, tested again and again. Some mass ranges for primordial black holes are ruled out, others remain possible, but so far there is no evidence that they dominate the halos. Bit by bit, the macho explanation faded. The cosmos does contain faint stars, stellar remnants, and black holes, but not in the overwhelming numbers needed. They are a minority, not the unseen majority. The missing mass is still missing. The ruling out of machos was more than a disappointment. It was a turning point. If ordinary objects could not account for dark matter, then something new must exist. Something beyond the matter we know. The weight of evidence pressed astronomers and physicists toward exotic particles, toward WIMPs, axions, and ideas not yet tested. Dark matter was no longer a question of overlooked stars. It was a question of hidden physics. As you lie here, let that thought comfort you. The process of elimination is not failure, it is progress. Each test, each observation, each ruled-out possibility brings us closer to the truth. The unseen is Anya, defined, clarified. Dark matter is not machos. It is not faint stars or scattered black holes. It is something more mysterious, something we have yet to discover. And that mystery remains, quiet, patient, holding galaxies together even now. If dark matter is made of new particles, how might we catch them? The challenge is immense. These particles do not shine. They do not absorb or scatter light. They pass through ordinary matter, almost as though it is not there. But scientists are determined. And so they have built experiments of extraordinary sensitivity, hidden away from the noise of the everyday world. These are the underground detectors, quiet chambers of liquid and crystal, waiting in silence for a single whisper of the unseen. Why underground? Because the Earth itself is alive with noise, cosmic rays from space, particles raining down constantly, natural radioactivity in rocks, even tiny disturbances from human activity. To detect dark matter, you must escape the clamor deep beneath mountains, inside abandoned mines, in caverns, shielded by kilometers of rock. Scientists carve out sanctuaries. Here, the detectors rest in stillness, away from stray signals, waiting for something rare. One of the most famous experiments is Xenon 1T, buried beneath Italy's Gran Sasso mountain. At its heart is a tank of liquid xenon, cooled to cryogenic temperatures. Photomultiplier tubes surround it, watching for flashes of light. The idea is simple, but profound. If a dark matter particle collides with a xenon atom, it may create a tiny burst of light and free electrons. That faint signal, almost unimaginably small, can be detected. The challenge is that such collisions are expected to be vanishingly rare, perhaps once per year, per ton of xenon. But in patience lies discovery. Other experiments take similar approaches. The LX-Ziplin detector in South Dakota, the Panda Axe experiment in China, and others around the world use noble gases like xenon or argon to search for the same fleeting flashes. Each new detector is larger, quieter, and more sensitive than the last, pushing deeper into the silence. These experiments have not yet found dark matter, but they have ruled out vast regions of possibility. The absence of signals is not failure, it is guidance. Each null result tells us where dark matter is not, forcing theories to adapt, narrowing the search. The silence itself becomes knowledge. Imagine what it feels like for the scientists who tend these experiments. They wait in the stillness of the underground caverns, surrounded by rock older than time, listening for the faintest murmur. Day after day, year after year, the detectors hum softly, catching photons from background radiation, recording data that may hold nothing, or may hold the first glimpse of the invisible. It is an act of patience, of faith, of trust in the quiet. There are other methods too. Some detectors use crystals that vibrate when struck by particles. Others use supercooled liquids that could release tiny bubbles in response to a collision. Each design is like a trap, set for a ghost, delicate, intricate, tuned to sense the nearly imperceptible. So far, the ghost has not been caught, but each experiment brings us closer. The search is not a single attempt, but a long symphony of silence, growing more sensitive with every note. And one day, perhaps, the detectors will capture a signal, a tiny flash, a faint vibration, a momentary ripple in the stillness. That signal would change everything. It would turn the unseen into the known. As you rest tonight, let the image of those detectors carry you. Picture vast caverns, quiet and dark, filled with tanks of liquid glowing faintly blue. Imagine scientists standing in hushed control rooms, watching screens flicker with data. Imagine the silence of rock pressing all around, the earth itself shielding the experiment like a cradle. Beneath the mountains, in the stillness of the world, humanity waits for a single touch from the unseen. That patience, that quiet, is as much a part of the story as the discovery itself. Far below the ground, on the border of Switzerland and France, lies one of humanity's most ambitious machines, the Large Hadron Collider, a ring of superconducting magnets stretching for 20 where particles are accelerated to nearly the speed of light, and then smashed together in bursts of energy that mimic the conditions of the early universe. Here, in this subterranean cathedral of physics, scientists search not only for known particles, but also for whispers of the unknown. Among those whispers may lie dark matter. The strategy is simple in concept, but intricate in execution. When protons collide at near light speeds, they shatter into showers of new particles. Detectors record the debris, tracking energy and momentum with exquisite precision. In theory, if dark matter particles can be created in these collisions, they would not leave tracks in the detectors. They would slip away silently, like ghosts leaving no footprints, but their absence would still be noticed. because something would be missing. Physicists look for missing energy, the imbalance between what goes into the collision and what comes out. If energy or momentum appears to vanish, carried off by invisible particles, that could be a clue. It is like throwing dice on a table and watching them disappear into thin air. You cannot see where they went, but you know they are gone. In this way, dark matter might be revealed not by its presence, but by its absence. The Collider has already given us monumental discoveries. In 2012, it revealed the Higgs boson, the particle that gives mass to the fundamental building blocks of the universe. That discovery showed the power of smashing particles together to expose hidden truths. But the Higgs was only a step. Scientists hope the same machine, or perhaps future colliders, will point toward the particles that make up dark matter. So far, the results are subtle. No clear dark matter particles have emerged, but the experiments have narrowed the field. They have told us where dark matter is not, much like the underground detectors that wait for collisions in silence. Together, these searches, one deep underground, one in the largest machine ever built, form a duet of patience and ambition. One listens for whispers from space. The other tries to create the unseen in bursts of energy. There are theories that dark matter might interact with the Higgs boson itself, coupling to the particle that ties mass together. Others propose that dark matter could be linked to supersymmetry, a framework that imagines every known particle has a heavier partner, still waiting to be discovered. If these partners exist, some could be the very particles that make up the cosmic scaffolding. The Collider could one day reveal them, hidden in the chaos of high-energy collisions. Imagine standing inside the cavern of one of the detectors, such as Atlas or CMS. The machines are vast, towering layers of sensors and electronics, each one waiting to record fragments of collisions that last less than a trillionth of a second. Streams of data pour from them. Billions of events recorded, sifted, analyzed, compared. Among those billions, perhaps one day, a single clue will appear, missing energy that cannot be explained away, a signature of particles slipping invisibly into the dark. For now, the search continues. New runs of the Collider push to higher energies, greater luminosities, more chances to glimpse the unseen. The effort is global, a collaboration of thousands of scientists, all chasing the same question. What is the universe made of? What is the invisible mass that binds the galaxies? As you lie here, imagine the hum of those machines deep beneath the Earth. Imagine protons racing around the ring faster and faster, colliding in bursts of light, like miniature stars igniting for an instant. Imagine scientists watching, waiting, searching for a gap in the pattern, a silence in the noise, a sign of dark matter passing unseen. Even in the most violent collisions, the invisible is quiet, and it is in that quiet that truth may one day be found. Not all searches for dark matter happen underground or inside particle colliders. Some take place in the quiet of orbit, where telescopes circle Earth, peering outward into the cosmos. These instruments do not try to catch dark matter directly, but to trace its influence across the sky, mapping its shadows in the bending of light and the clustering of galaxies. They are the cartographers of the invisible, drawing maps of a landscape we cannot see. One such mission is the Fermi Gamma Ray Space Telescope, which looks for faint signals that might come from dark matter particles annihilating each other. If dark matter can collide and convert into energy, the gamma rays it produces could light up regions rich with invisible mass, such as the centers of galaxies or dwarf galaxies orbiting the Milky Way. So far, the signals remain ambiguous, faint hints that might be dark matter or might be ordinary astrophysics. The search is ongoing, quiet and patient. Another is the Alpha Magnetic Spectrometer, AMS, mounted on the International Space Station. It sifts through cosmic rays, the high-energy particles that stream through space, looking for anomalies that might hint at dark matter's decay or annihilation. For more than a decade, it has collected data, cataloging billions of particles. Among them are subtle patterns, intriguing, but not definitive. Each piece of data adds to the puzzle, tightening the net around the unseen. But perhaps the most powerful tool for mapping dark matter is gravitational lensing surveys. Telescopes like the Hubble Space Telescope and future missions like the European Space Agency's Euclid and NASA's Nancy Grace Roman Space Telescope observe millions of galaxies. By measuring their shapes and alignments, astronomers detect the subtle distortions caused by dark matter along the line of sight. These distortions, when averaged across the sky, reveal vast maps of dark matter's distribution. The results are breathtaking. They show filaments stretching across billions of light years, connecting clusters like beads on invisible strings. They show halos around galaxies, sprawling far beyond their visible edges. They show voids, empty regions almost free of both light and mass. The cosmic web comes into focus, not in visible light, but in the statistical patterns of countless galaxies. It is a map of the unseen, drawn in the language of gravity. Imagine holding such a map in your hands. At first it looks like a tapestry of colors, regions of high density glowing bright, regions of emptiness fading dark. But then you realize what you are looking at: the skeleton of the universe. The galaxies you see through telescopes are the decorations, the bright ornaments. The dark matter beneath is the framework, the foundation. Without it, the ornaments would scatter, the web would unravel, the universe would be a different place. These space missions remind us that the search for dark matter is not confined to laboratories or theories. It is written across the sky itself. Every star, every galaxy, every arc of light is evident. The universe is the greatest experiment of all, and its results point again and again to the unseen. As you drift deeper into rest, imagine yourself floating alongside one of these telescopes, orbiting Earth in silence. Below you, the planet glows with the faint blues of ocean and the golden twinkle of cities at tide. Above you, the sky stretches black, dotted with countless stars. The telescope turns its gaze outward, gathering light from billions of years ago, painting maps of matter you cannot see. In its patience, in its quiet observation, you find peace. The universe is mysterious, but it is not unknowable. Bit by bit, it reveals its hidden frame. Even as you lie here now, dark matter is passing through you, not in violent bursts or storms, but in quiet streams, flowing invisibly, endlessly, like a river of ghosts. The Milky Way is wrapped in a vast dark matter halo, and within that halo, currents of invisible particles drift. Some are smooth, like a calm ocean. Others are streams, remnants of smaller galaxies torn apart by gravity, their stars scattered, and their dark matter stretched into rivers winding through our own. One of the most studied is the Sagittarius stream, born from a dwarf galaxy that is slowly being devoured by the Milky Way. Its stars arc across the sky in long trails, and with them flows dark matter, invisible but real. These streams may pass directly through our solar system, crossing Earth's orbit as though it were nothing. You do not feel them, you do not notice, yet they are there, flowing quietly, carrying the memory of ancient galaxies dissolved into our own. Scientists have tried to measure these flows. If dark matter particles exist, their motion relative to Earth could affect how often they might collide with atoms in detectors. The Earth itself moves through the halo as it orbits the galactic center, like a ship sailing through an unseen sea. At times, this motion may carry us against the current, at times with it, changing the tiny probability of collisions. In this way, the planet's motion through dark matter creates a subtle cosmic rhythm, a yearly dance with the unseen. Imagine Earth gliding through these invisible streams. Every second, trillions of particles pass through your body, through your room, through the ground beneath you. They leave no trace, but they are there, constant and steady, The walls do not stop them. The oceans do not slow them. The very core of the earth is transparent to their passage. You live immersed in a sea you cannot feel, a reminder that reality is richer than perception. Some theories suggest that streams may be denser in certain regions, forming structures like caustics or rings within the halo. If true, then there may be waves of dark matter washing across the solar system at different times, like tides in an invisible ocean. Such structures would be relics of the galaxy's history, fossilized flows from long-vanished companions. Astronomers dream of one day mapping these streams directly, perhaps by studying their gravitational effects on stars, or by detecting patterns in dark matter experiments on Earth. To glimpse them would be to uncover the hidden rivers of our galaxy, the unseen currents guiding our motion through space. For now, the streams remain speculative, but the concept is soothing in its imagery. You are not alone in the darkness. You are surrounded by invisible rivers, flowing quietly, carrying the weight of forgotten galaxies, weaving our home into the larger cosmos. To imagine them is to imagine the universe as a living system, where light and dark, seen and unseen, flow together in harmony. As you drift further into calm, let that vision rest in your mind. Invisible rivers crossing the sky, flowing through you, endless and patient. You cannot stop them. You cannot feel them, but you are carried within them, as gently as a leaf on water. Dark matter is not only distant, it is here, now, always, flowing through your life, as silently as sleep itself. Every galaxy you see shining in the night sky, every spiral, every cluster, every faint smudge of light in a telescope is wrapped in an invisible halo of dark matter. These halos are not decoration, they are the true bodies of galaxies, vast and heavy, stretching far beyond the stars we can see. If the Milky Way were drawn as a glowing disk, the dark halo around it would be a sphere, many times larger, encompassing the stars, the gas, the dust, and reaching far beyond, into space, we cannot map with light. The stars you see are only the tip of the iceberg. The halo holds most of the mass, silently binding the galaxy together. Without it, the arms of the spiral would unravel, the stars drifting into intergalactic darkness. The halos are guardians, cradling galaxies like shells around pearls. How do we know they are there? Astronomers trace their outlines through motion. Stars and gas clouds orbit at speeds that make no sense, if only visible matter is counted. The extra pull comes from the halo. By measuring these motions, astronomers can sketch the hidden sphere, mapping its reach even though it emits no light. Halos are not smooth. They are lumpy, filled with substructures, smaller clumps of dark matter that orbit within them. Some of these clumps host dwarf galaxies, faint companions with only a few stars, like the Magellanic clouds that circle the Milky Way. Others seem to be empty, dark satellites without light, pure gravity moving silently through space. Computer simulations predict hundreds of these subhalos around the Milky Way alone. Most have not been seen, but their gravitational footprints may one day reveal them. There are also hints that halos may extend farther than we once believed. The Milky Way's halo may reach out for hundreds of thousands of light years, overlapping with the halos of neighboring galaxies. In this way, the halos are not isolated, but entangled, blending into the larger cosmic web. Our galaxy's dark matter touches Andromeda's, long before the galaxies themselves will collide. One of the clearest proofs of halos comes from the phenomenon of galaxy clusters. In these enormous gatherings of galaxies, the halos overlap, merging into vast clouds of dark matter. The mass of these halos outweighs all the stars and gas combined, dominating the cluster. When light from distant galaxies passes through them, it bends, forming arcs and rings that mark the presence of invisible giants. These distortions are nature's way of revealing what cannot be seen. Imagine drifting through such a halo. There is no light, no glow, no texture. And yet, you would feel the pull of gravity from all sides, holding you gently, guiding your path. You are inside a cocoon you cannot see, as real as the stars, but silent, intangible. The galaxy's beauty is only possible because of the halo's embrace. The stars shine, but the halo is the frame that lets the picture hold together. Halos also tell the history of galaxies. Their shapes and densities reflect how galaxies grew, how they merged, how they were fed by the cosmic web. Each halo is a record, written not in starlight, but in mass. By studying them, astronomers can glimpse the childhood of galaxies, the invisible hand that guided their growth from faint sparks to shining spirals. As you rest tonight, remember that you live inside such a halo. The Milky Way's dark sphere surrounds you, stretching far beyond the stars. You are part of a structure so large it dwarfs imagination, yet so subtle it has no light. You are held in its gravity, carried in its silence, embraced in its invisible shell. The halo is not distant, it is here. It is home. Sometimes the invisible reveals itself most clearly in moments of violence, when galaxies collide, or when entire clusters crash together. The stars mostly pass through one another untouched, like grains of sand scattered in the wind, but the gas clouds within them slam together, heating into glowing X-ray fire. And the dark matter? It behaves differently still, sliding past, silent and unscathed. These cosmic collisions offer one of the most vivid proofs that dark matter exists. The most famous of these is the Bullet Cluster, a pair of galaxy clusters that collided hundreds of millions of years ago. To the eye, through X-ray telescopes, you see the hot gas concentrated in the center, slowed by the collision, glowing in bright shades of violet and blue. But when astronomers mapped the gravity of the system using gravitational lensing, they discovered something remarkable. The bulk of the mass was not with the gas. It was offset, lying where the galaxies themselves had continued forward. The dark matter had passed through the collision almost untouched, separating from the visible matter. This image, luminous gas in one place, invisible mass in another, became one of the clearest signs that dark matter is real. Modified gravity theories, which tried to explain galaxy motions without invoking unseen mass, could not account for this separation. The Bullet Cluster stands as a cosmic laboratory, showing that something unseen, something distinct from ordinary matter, must be present, and the Bullet Cluster is not unique. Other colliding clusters, such as the Musket Ball Cluster and the El Gordo Cluster, show similar patterns. Again and again, the visible matter and the gravitational mass part ways, like actors stepping off different stages. The galaxies and dark matter sail on, while the gas lingers, glowing and shocked by the impact. Each case is another piece of evidence, another whisper of the invisible truth. These collisions also tell us about dark matter's nature. The fact that it sails through with little resistance suggests that dark matter interacts very weakly with itself. Ordinary matter collides, compresses, heats up. Dark matter does not. It drifts, ghost-like, untouched by friction. But some astronomers wonder if dark matter might have some self-interaction, subtle enough to escape detection, but real enough to affect its behavior over time. These collisions help set limits, defining how invisible particles can and cannot behave. Imagine witnessing such a collision. Two clusters, each containing hundreds of galaxies, drift toward one another across millions of years. When they meet, stars slip past as though nothing happened. The gas flares in violent shock, spreading like fire, and the halos of dark matter glide silently onward, massive and invisible, pulling the galaxies with them. To your eyes, the sky would fill with arcs of light bent by the invisible, patterns only gravity could draw. It is almost poetic. In the chaos of collision, the unseen remains calm. Dark matter does not flare, does not glow, does not scream. It simply continues, steady as ever, holding the structure together. In violence, its silence is revealed. As you drift further into rest, let that image soothe you. Imagine the quiet persistence of the unseen, carrying galaxies forward even in turmoil. The bullet cluster is not just a scientific case study. It is a reminder that what is steady may not be visible, and what is invisible may be the most enduring of all. For decades, the dominant picture of dark matter has been simple: particles that feel gravity, and little else. They drift through stars, through planets, through each other, without slowing or scattering. They are silent passengers in the universe, touching nothing but bending everything. Yet some scientists wonder if this picture is too simple. What if dark matter has forces of its own? What if the invisible world is not only silent, but quietly active, with its own interactions hidden from our view? This idea is called self-interacting dark matter. The thought is subtle. Perhaps dark matter particles can bump into one another, exchanging energy or momentum, but without ever interacting with light. Such collisions would be rare, much rarer than those of ordinary matter. But they might shape halos in ways we can detect. Why imagine such complexity? Because some observations hint that dark matter's behavior is not always perfectly cold and collisionless. In the cores of galaxies, for example, simulations of pure collisionless dark matter predict steep density spikes, sharp cusps of invisible mass. But when astronomers measure real galaxies, especially dwarfs, they sometimes see flatter cores, as though the dark matter has spread out. Perhaps dark matter particles collide gently, redistributing energy, softening the peak. Colliding galaxy clusters also offer hints. In most cases, dark matter sails through untouched, but some systems show small offsets, slight separations that could suggest a hidden force at work. If dark matter particles occasionally scatter from one another, these subtle signatures could be the evidence. The implications are profound. If dark matter has its own interactions, then it may have a rich physics we have not yet glimpsed. There could be dark forces, dark charges, even a whole dark sector, mirroring the variety of the particles and forces we know, but invisible to our senses. Perhaps there are dark atoms, dark radiation, dark chemistry, an entire hidden complexity coexisting with us in the same universe, but never touching the light. This is speculation, yes, but speculation rooted in curiosity and evidence. Science advances by daring to imagine, and then testing those imaginations against the cosmos. Even if self-interacting dark matter proves false, the search will have taught us more about how galaxies grow, how halos form, how the unseen sculpts the visible. Imagine, for a moment, that this hidden sector is real. You float in the Milky Way's halo, surrounded by particles you cannot see. They drift, collide, exchange invisible whispers, shaping their own structures, their own patterns, while you pass through unaware. The galaxies you see would then be not only ornaments upon the dark, but neighbors to a parallel cosmos, a silent twin that shapes without shining. As you let this thought settle, remember that the absence of certainty is not emptiness. It is possibility. Dark matter may be simple, or it may be rich. It may be cold and passive, or it may carry hidden interaction. Whatever the truth, it holds galaxies together, guides the cosmic web, and shapes the fate of stars. Whether silent or self-interacting, its embrace is constant. And as you drift deeper into rest, think of that embrace. A universe filled with invisible particles, perhaps colliding gently, perhaps whispering forces we cannot detect. Around you, within you, through you, the unseen flows, quiet, patient, mysterious, and essential. If dark matter is real, and if it makes up the majority of matter in the universe, then a question naturally arises. Could it form structures of its own? Could there be stars made of dark matter, planets built from the unseen, perhaps even galaxies within galaxies, invisible but real? The idea of dark matter stars is both strange and beautiful. Ordinary stars shine because nuclear fusion ignites in their cores, fusing hydrogen into helium and releasing energy as light. Dark matter does not interact with light, so such fusion would not be possible in the same way. Yet some theories suggest that in the early universe, clouds of ordinary gas may have been seeded with dark matter. As the gas collapsed, the presence of dark matter could have altered its evolution. In some models, dark matter annihilation, particles colliding and converting into energy, might have produced enough heat to create dark stars. These would not glow in ordinary light, but in faint, exotic radiation, invisible to human eyes. Imagine such a star, vast, diffuse, powered not by fusion, but by the annihilation of invisible particles. To the eye, it would look like nothing at all, an empty patch of sky. Yet within that darkness, an energy source would burn quietly, unseen. Perhaps such stars once existed in the youth of the universe, shaping the formation of galaxies before fading into silence. What about dark matter planets? Could clumps of the invisible form spheres bound by gravity, orbiting like worlds in an unseen system? Here the answer seems less likely. Dark matter interacts so weakly with itself that it does not clump easily into small structures. Unlike ordinary matter, it cannot cool down, radiate heat, and collapse into compact forms. Instead, it remains spread out, diffuse, forming large halos but not tiny spheres. Still, some physicists wonder if rare conditions could allow dark matter to gather into compact bodies, objects we would never detect with light, but that would pull on nearby stars with their gravity. There are even wilder ideas. Dark galaxies, made almost entirely of unseen matter, with only a few stars scattered within them. Observations have revealed candidates, faint, ghostly systems, whose visible light is far too dim for the amount of gravity they exert. They seem to be galaxies where ordinary matter failed to ignite, leaving halos that are almost entirely dark. These ghost galaxies are rare, but they may be windows into a universe where the unseen dominates completely. Imagine floating through such a galaxy. There would be no glow, no spiral arms, no dazzling clusters. Perhaps a handful of faint stars would flicker here and there, but otherwise the sky would be empty. And yet, the gravity would be immense, the mass undeniable. You would feel the tug of a vast presence, invisible but overwhelming, a reminder that not all galaxies need to shine. These possibilities remain speculative, on the edge of science. But speculation is not folly. It is the beginning of discovery, the willingness to imagine what the unseen might build. If dark matter can form stars or galaxies of its own, then the universe is even richer than we dream. There may be entire landscapes of the invisible, parallel to the one we know, hidden not by distance, but by their very nature. As you let your eyes close, think of those hidden structures, dark stars glowing in radiation we cannot see, dark planets orbiting quietly, their gravity felt but their surfaces forever invisible, dark galaxies drifting like shadows through space, vast and silent. The universe may hold more than we can ever detect, but even in imagination, it offers comfort. The unseen is not empty. It may be full, rich, alive in ways we do not yet know. What if dark matter is not just one type of particle, but the gateway to an entire hidden world? Physicists call this possibility the dark sector, a parallel realm of particles and forces that interact with one another, but only faintly with us. In this vision, the universe we know is only half the story. The other half is invisible, silent, woven from laws of physics that run alongside our own. In our world, there are four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. These forces govern everything we see, from the pull of Earth's gravity to the light of stars, from the cohesion of atoms to the reactions inside the sun. But what if, alongside them, there are dark forces? What if dark matter particles feel attractions or repulsions we cannot measure, exchanging dark photons or dark bosons, dancing to rhythms our instruments cannot hear. This would mean the invisible cosmos is not just a sea of drifting particles, but a structured, dynamic realm. There could be dark atoms, where dark protons and dark electrons orbit one another, bound by dark electromagnetism. There could be dark chemistry, complex interactions that form structures we cannot imagine. There could even be dark stars or dark galaxies, held together not only by gravity, but by their own hidden forces, invisible civilizations of particles evolving silently in the shadows. To us, this sounds like science fiction, and yet, science has always expanded when we realized our world was only a fragment of a larger picture. Once we thought Earth was the center of the universe, then we discovered the sun. Once we thought our galaxy was the whole, then we discovered billions more. Perhaps now we stand on the edge of another expansion, ready to learn that the visible cosmos is only a slice of reality. Some experiments are already probing this possibility. Physicists look for subtle anomalies in particle collisions, signals that might hint at hidden forces. Others search for the faintest interactions between dark matter and ordinary matter, hoping that a rare collision might reveal the doorway to the dark sector. The results so far are inconclusive, but the questions remain alive. Imagine drifting at the boundary between the known and the unknown. On one side, stars burn, galaxies glow, light streams across space. On the other side, unseen forces shape unseen structures, a parallel universe overlapping ours, but never touching, except through gravity. You cannot see it, but you feel its pull. The stars themselves orbit within its grasp. Perhaps there are entire histories unfolding in that hidden world, a story as rich as our own, but written in particles we cannot detect. Perhaps the dark sector is silent only to us, while within itself it hums with activity, with interactions as complex as those that form atoms, molecules, and life. Whether or not this is true, the thought itself is soothing. It reminds us that mystery is not emptiness. The universe does not end where our senses fail. There may be depths upon depths, layers upon layers, invisible threads woven into the same cosmic fabric. As you sink deeper into calm, let yourself imagine the hidden universe flowing alongside our own, a realm of unseen particles, of invisible forces, of structures we cannot see, but that shape the cosmos we know. It is a quiet neighbor, a silent twin, a reminder that reality is always larger than perception. It is easy to confuse the great mysteries of the cosmos. Dark matter, dark energy. Their names echo one another, as though they were two sides of the same hidden coin. Yet they are not the same. They are separate puzzles, distinct in nature, united only by the fact that they are unseen. To understand dark matter fully, you must understand what it is not. And here, it is not dark energy. Dark matter is the invisible mass that pulls. It holds galaxies together, anchors clusters, shapes the cosmic web. Its gravity draws things inward, binding stars, sculpting orbits, clumping matter into halos and filaments. Dark matter is the skeleton of the universe, the unseen framework that gives it form. Dark energy, on the other hand, pushes. It is not mass, but mystery, a property of space itself. In the late 1990s, astronomers studying distant supernovae discovered that the expansion of the universe is accelerating instead of slowing under gravity's pull. Galaxies are racing apart faster and faster. Something is driving this acceleration, an unseen force pressing outward. That something was given the name dark energy. The contrast is striking. Dark matter pulls the cosmos together. Dark energy pushes it apart. Dark matter is heavy, clustering into halos, influencing galaxies. Dark energy is diffuse, uniform, spread evenly through space, not clumping but stretching. Dark matter dominates the scale of galaxies and clusters. Dark energy dominates the scale of the universe itself. The numbers are humbling. Roughly 5% of the universe is ordinary matter. Everything we see, touch, and know. About 27% is dark matter, the unseen gravity that sculpts galaxies, and the rest, about 68%, is dark energy, the mysterious pressure accelerating cosmic expansion. Most of reality, then, is invisible, and most of that invisibility is not even matter, but something stranger still. Imagine it as a grand contest written into the fabric of space. Dark matter pulls galaxies inward, gathering them into webs and knots. Dark energy pushes outward, driving the universe to expand faster and faster. The two forces balance and contend, shaping the fate of everything. Without dark matter, galaxies would not form. Without dark energy, the expansion would slow and perhaps reverse. Together, they determine the story of the cosmos. We do not yet know what dark energy truly is. Some suggest it is a property of empty space, the cosmological constant first proposed by Einstein and then dismissed, only to be revived decades later. Others imagine a new field, a dynamic energy that changes over time. Whatever it is not the same as dark matter. The two mysteries share a name, but not a nature. Think of it this way. Dark matter explains the shapes we see, why galaxies hold together, why light bends, why clusters abound. Dark energy explains the pace we see, why the universe expands the way it does, why distant galaxies recede faster than expected, why the cosmos is accelerating into the future. One shapes form, the other shapes time. As you rest, let that distinction settle. The universe is made mostly of the unseen, but even within the unseen, there are different roles, different mysteries, different truths. Dark matter is the quiet hand, holding stars in it. Dark energy is the silent breath, stretching space itself. Both are invisible, but each whispers in its own way. There is something profoundly humbling in the realization that most of the universe is hidden. The stars you see in the night sky are breathtaking, yes, but they are not the whole story. They are not even most of the story. The galaxies, the nebulae, the clusters of light, all of these belong to the 5% of the cosmos, made of ordinary matter. Everything else, the vast majority, is unseen. Dark matter pulls, dark energy pushes. Together, they shape a universe in which visibility is the exception, not the rule. What does it mean to live in a cosmos that is mostly invisible? For some, it feels unsettling, as though we are walking on a stage with most of the set hidden behind curtains. For others, it is inspiring, a reminder that mystery is not absence, but depth, that reality is richer than perception. The unseen does not diminish what we know. It expands it, reminding us that the cosmos will always exceed our grasp. Consider how human knowledge has grown. Once, we thought Earth was the center of everything. Then we discovered the sun. Later, we learned our sun was only one star among billions in the Milky Way. And then came the galaxies, billions more spread across space. Each time, the universe grew larger, and our place within it grew smaller. Dark matter continues that tradition, telling us that even the galaxies themselves are not the whole. They are bound by halos, shaped by scaffolding, suspended on invisible webs. Perhaps there is comfort in this. We do not need to see everything to know it is there. Just as you trust the ground beneath your feet, though you cannot see the atoms, so we trust the cosmos, even when most of it is hidden. Mystery is not a flaw in knowledge. It is the heart of knowledge. Without mystery, there would be no questions. Without questions, no discovery. Without discovery, no wonder. Dark matter also teaches us humility. For centuries, we assumed that the universe was illuminated for our benefit, that light revealed all there was to know. But light is only a thin slice of reality. Most of existence does not shine. Most of existence does not glow. To accept this is to accept that human senses are limited and that truth extends far beyond sight. You live surrounded by the unseen every day. Your memories, your thoughts, your dreams, they are invisible, yet they shape you as much as bones and blood. The rhythm of your heart is unseen. The air you breathe is invisible, yet essential. Dark matter is like that. On a cosmic scale, you cannot see it, but you live within it. You cannot touch it, but it touches everything. Imagine drifting into sleep with that thought. The universe is vast, but it is not entirely revealed. You are part of a story, written mostly in shadows, carried by halos you cannot see, shaped by forces you cannot feel. And yet here you are, resting in its embrace. The unseen does not diminish you. It holds you. It sustains you. It reminds you that you are part of something far larger than your senses can contain. Though dark matter remains invisible, humanity does not stop searching. The future of this mystery is written in the quiet halls of laboratories, in the hum of accelerators, in the gaze of telescopes not yet launched. Each new generation of experiments reaches deeper into the silence, narrowing the possibilities, preparing for the day when the unseen might finally speak. One of the most ambitious efforts lies in the next wave of underground detectors. The Relaxation experiment in South Dakota uses 10 tons of liquid xenon, watching for the faintest flashes of light caused by a collision with a dark matter particle. It is hundreds of times more sensitive than its predecessors, able to detect signals so rare they may occur only once a year in an ocean of atoms. Soon, even larger detectors will follow, each one expanding our reach into the invisible. At the same time, particle physicists are dreaming of new colliders, machines even more powerful than the Large Hadron Collider. Proposals for a future circular collider in Europe or a linear collider in Japan envision smashing particles together at energies far beyond today's limits. These machines could create conditions close to those of the early universe, where dark matter might reveal itself not as absence, but as presence, birthed in collisions and leaving traces in missing energy. Astronomy will also play its role. The Euclid spacecraft, launched by the European Space Agency and NASA's Nancy Grace Roman Space Telescope, will map billions of galaxies, measuring their shapes and positions with exquisite precision. These maps will reveal the large-scale structure of the cosmos, tracing the filaments of dark matter and testing theories of its nature. On the ground, observatories like the Vera Rubin Observatory will survey the entire sky every few nights, capturing the subtle distortions caused by gravitational lensing, building the most detailed atlas of the invisible universe ever made. There are even more daring ideas. Some experiments attempt to detect axions by listening for faint signals in resonant cavities, tiny oscillations in magnetic fields that could betray their presence. Others design ultra-cold crystals that might vibrate when struck by ghostly particles. The ingenuity is endless, each approach like a new instrument in the orchestra of discovery, all tuned to hear the silent notes of dark matter. Perhaps one of these experiments will succeed. Perhaps the next decade will bring the first direct detection, the first confirmed particle of the unseen. Or perhaps the silence will continue, and the mystery will deepen, forcing us to imagine new possibilities. Either outcome is progress. Science grows not only in triumphs, but in the narrowing of possibilities, in the refinement of questions, in the patient acceptance that the universe does not yield its secrets easily. Imagine the moment when the signal is finally found. A single collision in a tank of xenon, a faint vibration in a crystal, a missing fragment of energy in a collider. At first, it will seem like noise, then confirmed again and again, until the truth cannot be denied. Humanity will know that the unseen is no longer entirely invisible. The cosmos will grow larger once more, our place within it shifting, our story rewritten. As you rest, let that anticipation ease you. The mystery is vast, but it is not hopeless. The universe may be patient, but so are we. Somewhere, in the stillness of detectors or the silence of space, dark matter waits to be revealed. Until then, we drift within it, cradled by its gravity, dreaming of the day when the hidden will step softly into the light. For all the evidence, for all the maps of halos and webs, for all the arcs of light bent by invisible hands, there are some who wonder, what if dark matter does not exist at all? What if the universe is not filled with unseen particles, but instead, our understanding of gravity is incomplete? Perhaps the missing mass is not missing, but an illusion born of laws that work differently on cosmic scales. This alternative is called MOND, short for Modified Newtonian Dynamics. Proposed in the 1980s by physicist Mordechai Milgrom, MOND suggests that at very low accelerations, the kind experienced at the edges of galaxies, gravity behaves differently than Newton and Einstein predicted. Instead of weakening with distance as expected, it remains stronger, enough to hold stars in orbit, without the need for unseen matter. In this view, the galaxies spin as they do not, because of dark halos, but because gravity itself bends the rules. MOND was bold, and in some cases, it seemed to work. The rotation curves of galaxies, the very data that led Vera Rubin to dark matter, could often be explained by the modified law. Some small galaxies where dark matter halos seemed oddly shaped fit better with MOND's predictions. For a time, the idea offered an alluring possibility. Perhaps the cosmos was not full of invisible particles, but simply governed by a deeper law. Other extensions of this idea, known as modified gravity theories, have been developed since. Some try to adjust Einstein's general relativity, adding new terms or fields to explain the observed motions. Others attempt to merge dark matter and dark energy into a single framework, rewriting the equations of cosmology to make the universe whole without the need for invisible mass. But challenges remain. The bullet cluster, with its separation of visible gas and gravitational mass, is hard to explain with modified gravity alone. Gravitational lensing maps, which show halos distinct from luminous matter, also resist simple MUND solutions. On the largest scales, the cosmic microwave background provides evidence for dark matter that modified gravity struggles to reproduce. The elegance of MUND in galaxies is undeniable, but its struggles in clusters and the early universe make it less persuasive. Still, the persistence of these theories is important. They remind us not to take assumptions for granted. They push scientists to test every possibility, to ensure that dark matter is not merely a placeholder for ignorance. Even if dark matter is real, exploring alternatives strengthens the case, sharpening the evidence, ensuring that belief does not outpace proof. Imagine drifting in thought between these two visions of the cosmos. In one, you are immersed in seas of invisible particles, passing through you each moment, binding the galaxies, weaving the web. In the other, there are no unseen seas. Instead, the laws of gravity themselves twist at the edges, bending just enough to hold the stars. Both visions are elegant. Both are mysterious. Both carry a kind of beauty. Science does not demand that you choose tonight. It asks only that you remain open, that you rest in the questions as much as in the answers. Whether the universe is bound by unseen particles or unseen laws, it is bound all the same. The galaxies hold together. The stars do not drift away, and you, here on Earth, are carried in their embrace. As you close your eyes, let that duality comfort you. The truth may be particles. It may be new physics. It may be something stranger still. But whatever it is, it will not diminish the wonder. The mystery is not a void. It is an invitation. The search for dark matter is not a race with a finish line, but a journey stretching across generations. Each decade brings new instruments, new ideas, new ways of listening for the silence. Even if today's experiments do not reveal the invisible, tomorrow's may. The universe is patient, and so are we. In the coming years, observatories will open their eyes wider than ever before. The Vera C. Rubin Observatory in Chile will scan the entire night sky again and again, building a time-lapse of the cosmos. Its survey will capture billions of galaxies, mapping their shapes and motions with exquisite detail. In those patterns, in the subtle distortions of gravitational lensing, dark matter will leave fingerprints. The web of the unseen will become clearer, sharper, more undeniable. In space, the Euclid mission from the European Space Agency and NASA's Nancy Grace Roman Space Telescope will chart the large-scale structure of the universe by tracing how galaxies cluster and how light bends across cosmic distances. These missions will test not only the nature of dark matter, but also its relationship to dark energy. Together, they will give us the most detailed map of the invisible universe ever made. Meanwhile, underground laboratories will continue their vigil. Detectors are growing larger, more sensitive, capable of capturing collisions so rare they might occur once in a decade. The Relaxation experiment, the xenon detector in Italy, and the Pandax experiment in China all wait in silence, listening for whispers in liquid xenon or argon. New technologies, such as quantum sensors and superconducting devices, promise to push sensitivity even further, reaching for interactions once thought beyond our grasp. And on the frontier of particle physics, ideas for future colliders are taking shape. A future circular collider more than 100 kilometers around could probe energies never before reached, perhaps producing dark matter particles directly in high-energy collisions. Other projects, such as plasma Wakefield accelerators, could open entirely new methods of exploring physics at the smallest scales. If dark matter is a particle, there is hope that one day we will create it, measure it, and finally name it. There are even daring proposals to search for dark matter in space itself. Some suggest placing detectors on satellites, shielded from Earth's background noise, where they could listen for signals in the silence of orbit. Others dream of using gravitational wave detectors to sense the tiny tremors dark matter might cause as it passes. Each idea is a new attempt to hear what is not yet heard. The future of the mystery is not guaranteed. It may be that dark matter will remain hidden for decades to come. It may be that we will learn only by inference, mapping its effects without ever touching its essence. Or it may be that a single experiment, one quiet night, will see the signal, the faint spark, the first direct encounter with the unseen. When that moment comes, it will change everything. Imagine the day humanity finally understands what dark matter is. Headlines will celebrate, laboratories will rejoice, but beyond the noise, something deeper will stir. We will know, at last, the true nature of the substance that has shaped the cosmos since its birth. The galaxies above will no longer be mysteries of motion. They will be explained, their hidden halos revealed, their unseen skeletons named. And yet, even then, mystery will remain. For every answer, the universe offers new questions. If we discover dark matter is made of particles, we will wonder, how did they form? Why are they stable? Do they hint at other hidden forces? If it is something stranger, we will build new theories to follow the thread. The cosmos is not a book with a final page. It is a library, endless and expanding, each discovery opening doors to others. As you drift toward sleep, let that thought guide you. The search for dark matter is not only about physics. It is about wonder, patience, and the courage to ask questions without immediate answers. The unseen is not a wall, it is a path. And though we may not yet see where it leads, we walk it together, step by step, generation by generation, toward a truth vast enough to hold us all. Long before telescopes, long before equations, humans gazed at the night sky and filled its darkness with meaning. The stars became gods, the constellations became myth, the galaxies, unseen to the naked eye, became symbols of infinity. We told stories about the heavens, not only to explain them, but to explain ourselves. Now, in an age of satellites and detectors, we find ourselves faced with a mystery even greater. Most of the universe is invisible. Dark matter is not only a scientific puzzle, it is also a canvas for wonder, a mirror for our imagination. Consider the language we use. We call it dark, not because it is sinister, but because it is unseen. Darkness has always been a metaphor for the unknown, the hidden, the mysterious. To walk into the dark is to walk into uncertainty. To embrace the dark is to accept mystery as part of life. In that sense, dark matter is not only a physical reality, it is a reminder that not everything must be illuminated to be meaningful. Cultures have always woven the unseen into their stories. Ancient myths spoke of hidden realms, invisible forces, worlds layered upon our own. The Greeks imagined Hades beneath the earth. The Norse spoke of Yggdrasil, the world tree binding realms both seen and unseen. In Hindu cosmology, the universe is filled with layers upon layers of reality, many beyond perception. Dark matter, though discovered through science, fits into this lineage. It is a modern echo of ancient themes. The unseen is real, the hidden is essential. The invisible binds the visible. Artists too find inspiration here. Painters imagine galaxies wrapped in ghostly halos, webs stretching across canvases like lace spun from starlight. Poets speak of the gravity of absence, of the weight of silence. Musicians write of unseen harmonies, the pull of forces we cannot hear. Science gives us facts, but those facts ripple outward into culture, shaping the way we think of ourselves. Dark matter also challenges our sense of control. For centuries, human progress has been marked by illumination. The discovery of fire, the invention of light bulbs, the exploration of space. We shine light into darkness and feel that we understand, but here is a darkness that light cannot pierce. A mystery that resists the beam of every telescope. It reminds us that knowledge has limits, and that those limits are not failures but boundaries of wonder. And there is a gentleness in this mystery. Dark matter is not violent. It does not flare like a supernova or consume like a black hole. It is quiet, steady, patient. It holds galaxies together, shapes the cosmos, cradles stars. It is the soft hand of the universe, unseen but sustaining. In a world that often feels chaotic, perhaps this is the lesson. Not all power is loud. Some of the strongest forces are silent. As you prepare to drift into sleep, think of how dark matter connects us to the oldest traditions of humanity. We have always lived alongside mysteries, filling them with story, learning slowly to measure them, never fully capturing them. Dark matter is the newest chapter in that old tale. It is a reminder that science and story are not opposites, but companions. Both are ways of reaching toward the unseen. And so, the next time you look up at the stars, remember that what you see is only the surface. Beneath it lies a vast hidden structure, a quiet presence that has shaped everything you know. The darkness is not empty. It is full. It holds you. It holds the galaxies. It holds the future. The unseen is not absence. It is foundation. The night is deep now, and the universe is quiet. We have wandered through galaxies and clusters, halos and webs, collisions and streams. We have listened to the silence of underground detectors and the hum of colliders. We have imagined hidden stars, unseen sectors, parallel forces, and through it all, dark matter has remained what it always is. Invisible, patient, essential. Think of how vast it is. More than 4/5 of all matter belongs to the unseen. Every galaxy you admire, every star you wish upon, every nebula that glows in distant skies, all of them are ornaments on an invisible frame. You cannot see the frame. You cannot touch it. And yet, it is more real than the light. It holds the cosmos together, as surely as gravity holds you to Earth. There is something comforting in that. The most important structure of the universe is hidden. The strongest presence makes no sound. The most enduring substance leaves no trace in light. It reminds us that not everything essential must be visible. The invisible can cradle the visible. The quiet can sustain the loud. The dark can hold the light. Tonight, as you breathe slowly, imagine yourself floating in that invisible sea. The stars drift above you like lanterns on a vast black ocean. Beneath them, unseen, flows the weight of dark matter, carrying galaxies in its arms, stretching filaments across billions of light years, binding everything in one immense embrace. You are part of that embrace. You always have been. Perhaps we will one day know what dark matter truly is. Perhaps we will catch a particle, record a signal, name the substance that has remained nameless for so long. Or perhaps we will never hold it directly, destined always to know it only through its gravity, its influence, its whispers in motion. Either way, the truth remains. The unseen is real. The hidden is essential. The darkness is full. As your eyes grow heavy, let the thought of this hidden universe carry you. You do not need to see it. You do not need to grasp it. It is enough to rest in its presence, to trust that it holds you as it holds the stars. The cosmos is vast, but you are not apart from it. You are within it, part of its fabric, carried in the same quiet currents that carry galaxies. Breathe in and know that unseen particles pass through you. Breathe out and know that unseen gravity cradles you. The mystery is not something to fear. It is something to rest within. Like the night itself, the stars are ornaments of light. The galaxies are rivers of fire. But beneath them all is silence, steady and strong. And so, let go. Let the mystery of dark matter become the mystery of sleep. Let the unseen hold you as it holds the universe. Drift softly, drift deeply into the embrace of the invisible. The galaxies will remain, the stars will shine, the cosmos will hum, and you will rest. Carried gently in the arms of the dark, 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 gently in the arms of the